All right, welcome back to Mr. P Helps with Algebra. This is Unit 5, Topic 1, Lesson number 2, Bike Lovers. We're going to once again talk about piecewise functions. And we're going to start off with a warm-up about absolute values because we are going to get in absolute values in future lessons. So I'm going to show you now how to solve an equation, an absolute value equation. So absolute values means the distance away from 0. Now, I know that's probably what you've been told, but not always is the case. It's not always the distance away from 0, and which we'll talk about here in just a moment. So in this case, the absolute value of x, if the absolute value of x equals 7, then x can be either positive 7 or negative 7. So what you do is once you've got the absolute value isolated by itself, because we have nothing on the outside of the absolute value, what you do is you take whatever's on the inside of the absolute value and you set it equal to both the positive and the negative of that answer. Now, there really is nothing to solve for in this case. X equals both 7 and negative 7 because x was already by itself. But in this question, it would have been x minus 6 equals 3. I split it in half and I solve it again. X minus 6 equals negative 3. And now I'm going to solve it twice. Add 6 to both sides here means x is 9. And then add 6 over here and you get an answer of 3. So now, if I plug those numbers back in, it should work. 9 minus 6 is 3. The absolute value of 3 is 3. That works. 3 minus 6 is negative 3. And the absolute value of negative 3 is also 3 because negative 3 is 3 away from 0. All right, this one over here. So w plus 4 equals 11. And then w plus 4 equals negative 11. Set it equal to the answer and its opposite. Subtract 4 from both sides and you end up getting 7. And subtract 4 from both sides over here. Well, negative 11 minus 4 more makes negative 15. Once again, I can take those answers, plug it back in for w, and see that that is the correct answer. Now, in this case, now I talked to you about distance away from. So in this case, what you've really got is the two numbers that are 11 away from negative 4. So remember our quadratics where whatever was in the inside of the parentheses was always the opposite? Well, it's the same thing here. So these are the only two numbers that are exactly 11 away from negative 4. This is 11 above negative 4. This is 11 below negative 4. And these are the two numbers that are 3 away from positive 6. See how that works? Now, this one is really x minus 0. So this is really the two numbers that are 7 away from 0. So really, when you learn absolute value means the distance away from 0, that's only the case if the variable's by itself. If the variable has something else with it, then it's really a distance away from something else other than 0. All right, domain and range. So the domain means left to right. This function starts at a domain of negative 2, and x has to be between negative 2 and 7. And it can be equal to 2 and negative 7 because these are filled in circles. They're not open circles. The range, the lowest it possibly goes is negative 3. Y represents the range because that's the height, and the highest it could possibly be is 6. Range is the height. How low to how high, and domain is how far left to how far right. Same thing over here for the homework, so negative 1, 2, 3. So the domain is negative 3 is less than or equal to x, which is less than or equal to 6. The range, the lowest it possibly goes is negative 2, and the highest it possibly goes is positive 2. Now, once again, I use all or equal to's because all of these dots are closed circles, meaning filled in. They're not open circles. If they were open circled, then it would not have been or equal to. Okay, so we've got a piecewise function. This is a good activator. This is a piecewise function that only has two pieces in this case. So the first piece has a slope of up 30, right 60. Up 30, right 60 is the same thing as 1/2. So this is really y equals 1/2 x. So this is f of x. Okay, let me just write over here. F of x is equal to a set of, let's see, that's y equals 1/2 x, plus it has a y-intercept of 0. Now I could write plus 0, but I'm not going to because technically that's not needed. The second piece has a slope of, let's see, it goes from 30 up to 36. So that's up 6 for every right 60. So it looks like it's going up 1/10. I just simplified. 6 over 60 is 1/10 x. plus it has a y-intercept. Okay, this is going to be a little bit trickier. So if I continued this pattern, if it went down 6, 2, 4, it's going by 2s, right? 1, 2, 3. Yes, 1, 2, 3. For every left 60, I'd be at 24. So it's 1/10 x plus 24, comma. All right, so now we need domains. We need to know when was the function going at this linear pattern, from 0 to 60. 0 is less than or equal to x, which is less than or equal to 60, and this one is from 60 to 120. All right, so if you're able to follow that, then you have a pretty good idea of how a piecewise function works. The top piece, and this is the bottom piece. This is the equation of the line. This is when it does that. This is the equation of that line. This is when it does that, because that's the domain of when it was doing that slope. Okay, Michelle and Rashid love going biking, and every Saturday they have a particular route they bike they like to ride. Okay, below is a piecewise function that estimates the total distance. Great, so let's take a look. Here it is. It looks like we have 1, 2, 3, 4 pieces. Now, notice that these linear equations, now there's several ways you can write linear equations. You can write it in slope-intercept form, which is the way I love. You can write it in standard form, which is the way it's written right here. Or you can write it in what's called point-slope form. Now, they're all exactly the same equation. They can all be written, any linear equation can be written any of the different ways. But in this case, we've got ourselves standard form. Now, what's great about standard form is that this will always tell you the answer to the previous piece. All right, you'll see what I mean in just a second. So I'm going to graph this first piece. From 0 to 1, it's increasing by 16 per second. And it has a y-intercept of 0, so I'm going to start at 0. And then it must have gone up to 16. So there's the first piece. Now, the next piece starts at 16. Remember what I was talking about right here? Because see the overlap of the domains? And now, technically, this could be or equal to because they both answer the same for 1. So if you put 1, 1 minus 1 is 0. 0 times 6 is still 0. There you go. 0 plus 16 is 16. So there's the starting point. If I put 2 in for x, 2 minus 1 is 1. 1 times 6 is 6. 6 plus 16 is 22. So this is going to have a height of 22. Now, what you probably noticed by now, I was just taking this number and plugging it in and see where it ended. But really, what you should now notice is that the first number is the slope. This is really the slope times the previous number plus wherever it started. All right, so this one should have started at 22, and it's going to go up 14. So from 2 to 3, it's going to go up 14. So that's 2, 4, 6, 8, 10, 12, 14, up 14, right? All right, and it's going to go right there. Perfect. Now, something you probably have also said to me is, well, hey, Mr. P helps. Why didn't you just look at the next piece and see where it ended? Yeah, that's right. I could have done that. But what would I do on this last piece? Because there is no other piece that tells me where this one's going to start. Where this one's going to end. I'm sorry. So it does have a slope of 8. So it's going to go up 8 per second. It only goes up 1 second. So that's easy. 8 times 1 is 8. 2, 4, 6, 8. The next piece should end 8 higher. So let's double check that. If I put 4 in for t, I should get an answer of 44. 4 minus 3 is 1. 1 times 8 is 8. 8 added to 36 is 44. It works. What part of the bike ride did they go the fastest? Now, where does it increase the most? The very beginning. I guess they weren't tired. They were very energized in the beginning. This was the most because it goes up 16 per second. This only goes up 14 per second. That's pretty fast. So here's the fastest. Here's the second fastest. The last piece was kind of the third fastest, and this was the slowest. So I guess they got tired after that really fast start. What is the domain of this function? From 0 to 4. 0 is less than or equal to x, which is less than or equal to 4. What is d of 2? d of 2 is 22. How far have they traveled at 3 hours? At 3 hours, they've traveled 36 miles. What is the distance they traveled on their bike ride? Well, after 4 hours, when they're done, they've traveled 44 miles. That's a long ways. Sketch graph for the function d of t. I already did that. Great. Now, this one is exactly the same, but we have one slight difference, and that is that we have got some letters here. We got an A and a B. Now, I need to figure out what is A and what is B. What is the domain of this function? The domain is from 0 to 100. 0 is less than or equal to x, which is less than or equal to 100. What is the average rate of change during the interval of 20 to 50? Okay, so what I need to do is I would need to find where do they start at 20 and where do they end at 50? Now, that should be pretty easy because 20 times 1/4 is going to be, so if I plug 20 in for this, so 0 says it's going to be 5. So it looks like it started at 5 high. All right, so that's y2 minus y1 over x2 minus x1. Now, 50 minus 20 is 30. 1/5 of 30 is 6. 6 plus 5 is 11. All right, so there we go. So y2 minus y1, 11 minus 5 over 50 minus 20. There's your average height, which is going to be 6 over 30, which looks like an average rate of 1 over 5. Up 1 for every right 5 is the average rate of change from 20 to 50. Over which interval of time is the greatest average rate of change? The greatest average rate of change is whichever one of these slopes is going to be the greatest. 2/7 is greater than 1/8. Because this is, if it's in 8 equal parts and there's only one, that's less than 2 parts when each part is a little bit bigger. Now, 1/5 and 2/7. 2/7 is still bigger than 1/5. Then 1/4 is the same as 2/8. 2/7 is still bigger than 2/8 because each part is slightly bigger if there's only 7 equal parts rather than 8. Now, I did that because I'm good at fractions, but if you're not good at fractions, what you might have wanted to do is convert all these fractions to decimals. 1 divided by 4, 1 divided by 5, 2 divided by 7, and 1 divided by 8. Do all those separately and see which decimal is the biggest. And you'll see the 2/7 is going to be the biggest. Honestly, I don't know what 2 divided by 7 is, but I'm better at fractions, so I did it my way. Sorry, you do it your way. Complete each statement, then describe the statement in context of the situation. What is D of 30? All right, D of 30 equals, what I need to do is figure out, first of all, which piece do I need to use? 30 is between 20 and 50, so I got to use this one. 30 minus 20 is 10. 1/5 of 10 is 2. 2 plus 5 is 7. So what does that mean? After 30 minutes, is this minutes? I'm just going to assume it's minutes. I think it is. After 30 minutes, they have traveled 7 miles. That's what I would write right there. If I put 64, first of all, I have to use this piece because 64 isn't between 0 and 20. Isn't between 20 and 50. 64, just put it into this equation. 64 minus 50 is 14. 2/7 of 14 is 4. 4 plus 11 is 15. So that means after 64 minutes, they have traveled 15 miles. D of 10, well, which function do I need to use? I'm sorry, which piece of the function do I need to use? And that would be the first piece, because 10 is between 0 and 20. And 1/4 of 10, let's see, 10 divided by 4, that's going to be what, 2.5? Sure is. So after 10 minutes, they've only traveled 2.5 miles. All right, there's your answer there. And the next thing you can do is you can simply graph it. So from 0 to 20, so you would need to go from 0 to 20, they would go up a slope of 1/4, up 1 for every right 4. And you're going to get a linear line here. Actually, I'm going to go ahead and stop it here. In fact, I'm going to show this really quickly, and then I'll stop, and hopefully I'm going to not make it, I'm not going to run out of time. Determine the value of C. Now, remember what we did last time? Remember how when it's in standard form, this number is always the same as the previous one ended. So that's what I'm going to do first. I'm going to put 10 in for x and solve. 10 squared is 100. 1/4 of 100 is 25. Now, I know if this answer is 25, 0 in for x is 0. 0 times 1/4 is 0. So it started at 0. I'm going to end it at 25. That means this piece has to also start at 25. So now, not all piecewise functions are continuous. Now, I do want to point that out, that in the directions it said that the following is a continuous piecewise. Like I said, not all piecewise functions touch. They're not always connected. But since it told us it is in the directions, then we know that whatever this ended at, this one must have started at. I realize I'm at 1 minute left. So I now know that C must have been, let's see, so this one must be 25. Because 25 is the starting point. Now, if I want to find, is that the only value in here I need to find? Yes, it is. Okay, so that was it. So, done. Great. Thanks again for watching. Please give it a like to help you learn something about piecewise functions, and subscribe if you haven't done so already. Thanks again for watching. Have a great day.